G'day all. Our final experiment is a little different because it's not a real world experiment. It's an online simulation experiment. So basically, online simulations are a research interest area of mine. They are a way to do virtual labs. They're good in a situation where the lab is too dangerous or would take too long, or your school doesn't have the apparatus, or for a number of other reasons that you might want to do a virtual laboratory. I encourage people to do as many real laboratories as they can, because if the students can grab things and hold things and touch things, it's more memorable than another thing on a computer screen. But at the same time, as I say, a virtual lab can help you access concepts where you can't do the real lab. And today's is one of those concepts. It is about natural selection, which is part of evolutionary theory. It's not the whole thing, but it's one piece. That is, within a population of a particular species, there will be particular individuals that have genetic characteristics that make it easier for them to survive or easier for them to breed. So easier for them to survive might be things like being more camouflaged so predators don't eat them, or having a shell or some kind of carapace that makes them harder for predators to eat, or being smarter and better at hiding and sneaking. Things that help them breed might be being beautifully coloured, or having a particular dance or a particular song that attracts a mate. So those kind of characteristics in a population will be selected for, in that the ones that survive long enough to pass on their genes, and the ones that are most successful in mating to pass on their genes, are the ones who will create the next generation. The ones who aren't successful, they get eaten before they procreate, or they never mate in their life, won't pass on to the next generation. And so there'll be more and more of those characteristics that help survival and breeding. That's what natural selection means, that there's nothing magical about it, there's no intention, no goal. It just means if you're more likely to survive, then you're more likely to pass on your genes to following generations, and therefore your characteristics are more likely to increase in the population of your species. I hope that makes sense. So that's obviously a concept that's really difficult to be able to illustrate in the real world. Things tend to live too long to be able to do multiple generations in a classroom, or the things that don't. So things like bacteria have a lot of generations quickly, but they're very hard to observe in the classroom because you have to look at them under the microscope. And the kind of characteristics they have are quite hard to see with the naked eye. So a bacterium under microscope just looks like a little moving blob. And, it's not as though you can see which ones are the prettiest or have the best song or dance or are better at avoiding predators, or in this case, avoiding antibiotics. So instead of using a real experiment to look at natural selection, we'll use a simulation. Now, a number of different people make simulations, including commercial companies, but the PhET project, I'm not even sure what the acronym stands for. It's PHET. It's at the University of Colorado. I think the PH stands for physics, because they started out making physics simulations quite a couple of decades ago, but they've now branched out and they do quite a lot. So it's really easy to find. Just Google PhET, PHET. The computer's not cooperating. PhET, and the first thing that comes up, PhET, free online physics, chemistry, biology, earth science. So click into that. And there's a large number of different simulations there. I can go into the biology section, but you can see that there are simulations for the other sciences as well, and some for mathematics. Rather than go down through all of these, there we are, natural selection. It's this one. And this particular natural selection one uses bunnies. Now, there are a couple of ways to do it. There is download or embed. I would suggest using the embed one. You can download it, but that involves updating the version of Java on your computer and may or may not work. If you click on the embed one, that's not helpful, sorry. No, it looks like I have to download this one. So I'm going to download it, and it's going to... different browsers will behave differently, but my downloads for Chrome are here. It asks me, do I want to keep it? Yes, I do, so I'll keep it. I will drag it to the desktop, and double click on it. And my Apple preferences aren't allowing me to do that. I'm going to have to go in and fix that. So I'll pause the recording for a minute and fix something. But you see what I mean about downloaded ones. It can be a little bit of a hassle. See, talk to you in a minute. Okay, and we're back. Now some of you will have Macs, some of you will have Windows machines, so it might look a bit different on your machine, but you should be able to get this guy going. As I say, it may ask you to update Java on your machine, in which case you should do that. It shouldn't be a huge hassle. Now, we've got one bunny. One bunny is not going to breed, so we can add a friend. Oh, no good. All right, I can add a friend. So now I've got two bunnies, and when there are two bunnies, usually there are going to be more bunnies. Now, what can you see? You can see bunnies hopping around, and suddenly there are lots more. You can see the number increasing. So we've got a graph down here. And one of the things with interactive simulations is that over time you get, you can get data, real data from them. They're not just animations. They're not just pictures of what's going on. They're real experiments. Now you can see I've got a problem. I've got an overpopulation problem. There are too many bunnies. They're going to eat all the food, and over time their population is going to fall. Bunnies have taken over the world. So you can see a world entirely covered in bunnies. So that was a problem. We didn't have any natural predators, and this is one of the reasons why rabbits are a problem in Australia, because they were introduced from Europe and they don't have natural predators in Australia. So we needed things like the rabbit-proof fence to try and keep them under control. You can't have a rabbit as a pet in Queensland in order to keep them under control. So rabbits are an interesting problem. So let's try starting again so we can reset the simulation. I've got to find the reset button. Reset all down the bottom here, bottom right hand side. See that? So reset all settings. Okay, so now I've just got my one bunny. Let me select using wolves. So I'm going to add enough bunnies that it doesn't immediately get eaten. So I've got my breeding pair again. So I start with my breeding pair, and then they start to increase. And then I put some wolves into the environment, about a pack of wolves, and they are going to select the rabbits. They will come through every now and then. So you can see what's happened to the population. It went up, and then it came back to the original 2. And then if it pops up again, the wolves will come through and take it back down to a sensible number. So you can see now I've got an ecosystem that's in balance. I used to have one that was out of balance and the bunnies predominated. If I have a predator and a prey, obviously real food chains are more complicated than that, but that's a good start. That will keep it under control. Let's try switching from an equatorial environment with a brown to an Arctic environment with white. So our white rabbit is better adapted to that environment, but we seem to have got down to one rabbit, which is not going to be a sustainable population. So we might end up with an extinction event once our one rabbit dies off. So I might just reset it again. So let's try a slightly different one. We'll add a friend. So we're going to get some more white rabbits. They're white rabbits in a brown background. And let's let them grow, population grow a little bit more before we add the wolves. So we'll get up to a bigger population, and then we'll put some wolves in. Okay, they're going to cull the population back down fairly quickly, but not back down to 2, back down to 5 or so. Now what if I make a mutation of brown-furred rabbits? So in a later generation, the rabbits breed, and some of them are going to have brown fur. Oh, there's one. First brown-furred rabbit. Is he easier or harder to see on the sand than a white-furred rabbit? Now suddenly we've got a brown-furred rabbit who has survived, and has survived the wolves because they couldn't see him. Okay, I'm not going to belabor the point. You've got a number of variables. You can add long tails on rabbits as a mutation, see whether that improves their survival. You can add long teeth on rabbits, see whether that improves their survival. You can use food as a control. You can use different environments. You can do different charts. There's a bunch of stuff going on here with this simulation. So this is a bit of an exploration, but what I want you to do is explore it, explore the possibilities, and then do an experiment with just one mutation. What happens if you add that mutation? What happens to the population of the rabbits over time? If I had enough rabbits here, would I get all brown rabbits after a while in the brown environment, or more brown rabbits than white? What do you predict? What do you observe? How do you explain it, etc.? Oops, we've had a bunny extinction crisis. So I'm going to leave it there. But hopefully you're learning something about both natural selection, which is one of the elements of evolution, and about interactive simulations and how we might teach with them. Have a good one. See ya.